Hello, this video is about distance-time graphs, how to plot them and how to interpret them. So first of all, let's just talk about axes. Time always goes on your x-axis in a graph like this. It's your independent variable, so that's the x-axis, and then on the vertical we plot distance. Now let's just think about the equation. Speed equals distance over time. Now that's an equation you use a lot in science, but also if you think about it from a maths point of view, this y over x thing is kind of your gradient. So distance over time is your gradient. Speed is your gradient on a graph like this. So the steeper the gradient, the faster the speed that you're experiencing for the object you're plotting. So now let's just put that knowledge into context and look at interpreting this graph. We've got some object moving for some period of time, and I've broken it into 4 sections. In the first section, time is passing and distance is increasing. In other words, the object is moving. But in the second section, the distance is increasing at a higher rate. The gradient is steeper. That's the object moving faster. Now, very often you're asked what's happening in this bit of the graph. Well, if the distance isn't changing, then the object is stationary. It's not changing distance during this period. And then in the last period, it's returning back to its starting point. That's why the distance is decreasing to 0 quite fast again. So main takeaways: distance on the vertical, time on the horizontal. Gradient relates to the speed of the object, and particularly remember a flat line means an object's not moving. Steep is fast, shallow is slow. Thanks very much for watching. Hope that was helpful.